And let's practice this on to more examples. I'm rewriting the formula that we are aiming for. Today's key formula for this lesson. Okay, let's take a sequence like this. 1 minus something like this. The problem is, first of all, with the minus sign, because here it's minus and here it's plus. We already know how to deal with that. And the second thing is that this and this are not the same. Here it's 2n minus 2 and here it's 4n minus 11. We proceed as follows. I'm rewriting everything that's inside. Right away, I'm dealing with this minus sign like I did in the previous example, putting the minus on top. So, I've already tidied that up. I raise it to the power that's here, to the expression that's here. If it's 2n minus 2 here, then I write 2n minus 2 here. I'm making another one of these huge square brackets. I'm drawing a fraction line here. Below the line, I rewrite what I wrote here. And above, what was there before, which is 4n plus 11. And now I know that everything inside here approaches e to the minus 3, here, inside this square bracket. And I have to calculate this on the side. So, I'm calculating. E approaches infinity. I factor out the highest powers. I'm left with 4 over 2, which is 2, you agree, right? It turned out that this time it approaches 2. So, our result will be e to the minus 3, because this inside, according to this formula, approaches e to the minus 3. And to what power? To 2, because it turned out that the exponent also tends to 2. Minus 3 times 2 is minus 6, so e to the minus 6. Right? Simple. You just have to take a few steps here. First this, then the parenthesis, then this to that. And remember what was happening here. But later it's simple and intuitively understandable what you are doing. Let's take a sequence like this. Sometimes there are surprises here. There will be a surprise here. Plus is there, everything's fine. It only doesn't match here and here. Okay, I'll do it the old way. Look, I've already written it down. I raise it to the power that is here. There was n squared here, I raise it to n squared. I make a square bracket. At the bottom in the denominator, I add, here in this exponent, in the denominator of this exponent, yes, I add what I added here, which is n squared. And at the top what was before, which is n minus 1. I'm calculating this on the side now. Limit. Remember to maintain formalism here. Don't do it with scribbles in the margin, without a limit, or anything like that. Just write a nice limit for the professor. Calculating this limit is also an important part of the task. You can't just do it in your head, or in the margin, or on another piece of paper. Write the limit of this expression normally on the side. You factor out n at the top. And now there will be a surprise, because this approaches 0. Do we agree? N and n squared are reduced, but n squared partially, because n will remain at the bottom, so 1 over n will remain. As n approaches infinity, 1 over infinity, which is 0. We did these kinds of things in the first lesson, so this time it approaches 0. So, what will our result be? E to the 7th, so inside it tends to e to the 7th, according to this formula. Inside, in the square brackets, e to the 7th and to 0. E to the 7th and to 0 is e to the 0, because 7 times 0 is 0, and e to the 0 is 1. It can also be like that. Why not?